If you look at the amount of benefits that modern digital technology has brought to mankind, I mean, now virtually everyone has access to a mobile phone. Internet, roughly half the people in the world have access to internet. Enormous amounts of optimization of mankind through the use of data. And basically everything we use, touch, and own in our lives is basically soon being connected. Ericsson is predicting 50 billion connected devices. So that's the state of humanity and mankind. Now let's go to companies. Because what is the interesting thing about companies? If we look at the state of companies, we see exactly the opposite. If we look at the Fortune 500, the companies that were on the Fortune 500 in 2000, how many of those companies were still on the Fortune 500 in 2014? Well, the answer is that more than half of the companies that were on the Fortune 500 in 2000 are gone from the list in 2014. It doesn't mean that they've completely disappeared, but perhaps something happened to them like what happened to Nokia. So on the one hand, humans are doing better and better, and on the other hand, companies are actually having a harder and harder time to stay competitive. And I think that this is important, especially in newer economies such as what we see here in Eastern Europe. And one of the drivers is basically predicted by this gentleman. I'm not sure if you know him, but you use a product that he has invented on a daily basis. This is Douglas Engelbart, the inventor of the computer mouse, and what he basically claims is that the digital revolution is far more significant than the invention of writing or even printing. And I think that's a big statement, because if you look at the history of writing or printing, those were moments in the history of mankind where we fundamentally shifted course. They had really fundamental things happen, and that's what's happening right now. And he claims that the digital revolution is even bigger than those earlier revolutions. So what we now see is that companies are increasingly being disrupted by this digital transformation. The average tenure on the Fortune 500 is now down to 10 years. And why is this? It's because companies fail to innovate and develop core capabilities, and digitalization is basically the new disruptor. Now, everyone talks about digitalization, but I wanted to at least be a little bit precise in what we talk about. What is digitalization? This is the definition from Gartner. Digitalization is the use of digital technologies to change a business model and provide new revenue and value producing opportunities. It is the process of moving to a digital business. And then many people think, Jan, this is all business. What does this mean for us? Here you have an assessment of Boston Consulting Group, who basically says, yes, it is about adding software to products. But it is also about data-driven services, it's about digital services, it's about software products, so pure software products. And it's about R&D is affected by it, but also sales and channels and marketing, manufacturing, HR. It's not just about going agile, but it's also about platforms, it's about analytics, it's about a digital partner ecosystem. So everything that is happening in the company these days is basically being touched by this digitalization transformation. Now, with that, I know you are having a rough conference, so I thought I'd keep it really simple. I give you 3 key takeaways, the only things you have to remember from this talk. The first is speed. Improving speed drives any other is more important than any other improvement that R&D can provide to the organization. And the goal is continuous deployment of new functionality. Whether you talk about your mobile phone, you talk about your website, you talk about your car, you talk about your television, you talk about your computer, everything is moving towards continuous deployment of new software. The second is effective use of data. So what are we doing with all the data around us? And I will come back to some of the AI implications of this. As well as the business and software ecosystems around us are increasingly important to exploit and to monetize from a business perspective. And then finally, summarizing all of this, we are moving towards a new business operating system that is organized around empowerment and autonomy of people. The whole notion of hierarchical organizations with big bosses at the top, slightly smaller bosses below that, etc., all the way down. All those traditional hierarchical organizations are going away and are going to be replaced with empowered and autonomous organizations where there are no bosses, there are no managers, and I think that that's an interesting development. So what I was hoping to cover with you, and I'll try to leave the second keynote speaker a little bit of time, I promise, is I will tell you briefly about who I am. Then I want to talk about a few trends in industry that I think are relevant. And then I want to talk about the 4 dimensions of this new business operating system, which is around speed, around data, and to some extent AI, around ecosystems and then empowerment, and then we'll see conclusions. So very briefly about me, I used to be a young and innocent professor of software engineering in Sweden and in the Netherlands. Early 2000s, I get a call from Nokia. You remember Nokia? Yeah? You remember what happened to Nokia? I had left by that time, just for the record. So before I knew it, I was running one of the research labs at Nokia Research Center. Beautiful job, you know, 6 sites around the world, 200 people working for me, absolutely fantastic. But I must admit that after the 3rd winter in Finland, not sure who has been to Finland in winter, my family explained to me that there were warmer climates than Finland. And at the same time, I was talking to a company called Intuit. For all the Intuit is world famous in all of the United States, which for most Americans is the same thing, actually. So I was a VP for Intuit. Intuit is based in Silicon Valley. I did that for several years. And now since 2011, I'm back in Sweden. I run something called Software Center that I'll talk about. I run a small consultancy that I will not talk about. And I'm involved in a number of startups as advisory board member or chairman, or as angel investor. So if you plan to start a company, you have a good idea, come and talk to me after the talk, okay? Yeah? Okay, good. Software Center is a collaboration between now 12 companies. Since the thing was made, the bio was made, we actually added a company called SEFT and 5 universities. And the goal of it is to improve the digitalization capability of the European software-intensive systems industry. We have no public money in this initiative. All the research is funded by the companies in the Software Center. So we have Tetra Pak and Saab, and this is not a bankrupt Dutch car company, this is the Swedish defense company. We have Siemens and Bosch, we have Qualcomm, a local SME. SEFT is China, Europe Vehicle Technologies, part of Geely Group, which also owns Volvo Cars. Access Communications, now part of Canon. Volvo Cars, Volvo Trucks, we have Boeing in there through one of their daughters called Jeppesen. Ericsson, you may have heard of Ericsson, they do telecommunication. And Grundfos, and then we have several universities. We do research around continuous integration and delivery, around architecture, around metrics, around customer data and ecosystems. We look into autonomous systems and AI. We look into Internet of Things, those kind of topics. And I do not only talk to those what are traditionally metal bending companies. We also have quite a few relationships to companies like Booking.com, Spotify is a Swedish startup in case you wondered, Rovio from Finland, Klarna is one of the Swedish prides around basically paying for stuff you buy online afterwards. King.com is the company behind Candy Crush. You know Candy Crush? No one will admit to having played Candy Crush, but everyone knows someone who has played Candy Crush. I don't know why that is. And then, of course, Microsoft. We have good collaboration with the data analytics team at Microsoft, basically. So that's who I am and where I come from. I hope that wasn't too painful. I took off my jacket. I just wanted to show you that I brought it, especially for you. It's getting a little warm here. Trends in industry. The first thing, if we look at the Gartner technology hype cycle, look at the items on the hype cycle. Look at the topics that are there. Things like augmented reality, mixed reality, connected home, autonomous driving level 4, that means self-driving on the highway, blockchain, virtual assistants, IoT platforms, deep learning nets, etc., etc. All those things are driven by software. Virtually everything we do these days is driven by software made by people like us. And then here's another slide that basically drives this home. You know, the first thing that I do when I get out of bed in the morning is I brush my teeth. How do I brush my teeth? Well, I use an Oral-B electric toothbrush. 2 years ago, Oral-B announced a software ecosystem for toothbrushes. I'm not kidding. They put Bluetooth in your toothbrush, and after you brush your teeth, through the mobile app, you can get feedback on the quality of your toothbrushing experience. How cool is that? Yeah? And then throughout the day, whether we talk about logistics, or we talk about infrastructure, or we talk about sports, or forestry, or agriculture, electricity generation, self-driving cars, even garbage collection these days is driven by software. We visited a startup in Finland called Enevo. They put ultrasound sensors in those big recyclable waste bins. They are connected through a 2G connection to the home office, and basically every hour or so they send an ultrasound pulse They measure how full the waste bin is, and then the garbage collection company does a dynamically mapped out garbage collection route to only empty those bins that are basically need to be emptied. Yeah, 50% reduction in garbage collection cost. Those are the kinds of benefits that we're looking for these days, right? But if you look at self-driving cars, driven by software, robots driven by software, in defense, moving towards drones, driven by software. Even the most backwards industry, construction, which is the worst industry from a productivity improvement perspective around. There was recently an Economist article that said since 1947, construction had managed to accomplish 0% productivity improvement. Zero. Yeah, agriculture has done something like 1,600% of productivity improvement since then, but construction is zero. Even construction is now kicking and screaming being dragged into the 21st century. It's amazing. But what no one really thinks about is why is this? And the important thing why this is because of the cycle of innovation. And this is important to understand. I'm sure that you've all read The Lean Startup by Eric Ries. He did quite a bit of his research and his work at Intuit. He interviewed several people there. And he basically talks about the build, measure, learn loop. It says you have an idea, you build a product based on that idea, you put the product in market so you can measure how it is actually being used. That gives you data. From this data you can learn, and from these learnings you will get new ideas. And the basic idea behind innovation is the faster you can go through the build, measure, learn loop, the more innovative you are. Now let's compare, let's look at automotive. So here is a car platform. A car platform typically lives about 10 to 15 years, which means that I go through a build, measure, learn loop once every decade and a half. Yeah, that's pretty slow, right? I mean, even in an entire career, if you work 45 years for the same company, you will go through 3 platforms as a car company, right? Now we look at a car. This is an XC90. It's now getting a beautiful car still, but Volvo has even nicer cars if you haven't looked at them recently. They're based in Gothenburg, where I happen to live. I'm biased, maybe. A car project typically takes 3 to 4 years. Yeah, so I go through a build, measure, learn loop once every 3 to 4 years. But what about car software? Well, car software goes through a build, measure, learn loop every day or every week, which means that I can go through my build, measure, learn 100, 200, 500 times faster than any other technology that exists in the market. Yeah, this is why everything is moving to software, because software gives me the speed to go through my innovation cycle that I cannot accomplish with any other technology besides software. And we can see this. If we look at some of the research by Ebert and others, we can see that the amount of software in typical systems goes up with an order of magnitude every 5 to 10 years, depending on the industry that you're in. And if you think it's hard to build 1 million line of code systems, you know, the architectures, ways of working and tooling, they don't even work when you're trying to build 10 million lines of code systems. And by the time you finally figured out to build 10 million lines of code systems, those solutions will not work when we're building 100 million lines of code systems. And I'm not kidding about 100 million lines of code. A modern car like the XC90 has now well over 100 million lines of code in the car. Yeah, you can see an exponential growth of the size of the software. So that's just the size of software. Then we go to data. Yeah, it's very hard to find accurate numbers, but one reference that I found says that there is 50 terabytes of data is created every second. 204 million emails are sent. I'm not sure, there are quite a few young people in the audience here. I'm not sure who's in the dating scene. But if you look at Tinder, I've heard of this. I've been married way too long to know what Tinder really is all about. But according to my colleagues, at Tinder you swipe left or right. Is that correct? Anyone can confirm or deny that statement? No one will do that publicly. That's interesting. But over the last minute, around 500,000 swipes left or right or left took place on Tinder. If you look at YouTube, if you wonder why your kids never stop watching YouTube videos, it's because every minute of the day, 76 hours of video is uploaded to YouTube. The amount of data is staggering. And the interesting thing is, this is just data generated by human beings. And with all the devices coming online, the amount of data generated by humans will only be a small fraction of the amount of data that will be generated by all the machines that are connected to us. Ranging from our cars to our phones to our running sensors to factories to whatever you can think of, everything will generate vastly more data than what we're generating as humans. This soon will only be a very small part. And then the final thing is speed. I cannot stress speed enough. Here you see 4 products: Quicken, eBay, Facebook, and Angry Birds. You can see how long it took each of those products to get to 1 million and to 50 million users. Quicken was introduced in '94. It's a personal financial management product. 6 years to 1 million, we never reached 50. This is an Intuit product. 10 years later, eBay comes along. They reach 1 million in 30 months and 50 million in 80 months. 10 years later, Facebook comes along. 10 months to 1 million, 44 months to 50 million. 5 years later, Angry Birds comes along. Angry Birds hits 50 million users in about a month. They don't even know how long it took them to get to 1 million. It just flew past, basically. Then if you look at newer trends like Pokemon Go, anyone having kids playing Pokemon Go in this audience? Yeah, now 2 summers ago, a complete explosion of how Pokemon Go was basically being used. So what we see is that from a customer adaptation perspective, we're constantly accelerating. Now, if you don't like customers, but you like money, yeah, any company people in the room here? Except for the Intel folks? Yeah, a very quick example. Here I have a company. The company sells a product at a rate of $1 billion a year. Most companies express their R&D budget as a percentage of revenue. So to keep it simple, I put it at 10%, yeah, because in Sweden we have some issues with our math education, so I thought I'd keep it simple. And that gives me, and I have a new product development cycle of 12 months. Now I'm going to give you 2 alternatives. The first alternative is I'm going to focus everything on becoming more efficient. And lo and behold, I'm successful. I'm 10% more efficient. And this basically gives me a reduction of $10 million in development costs. That's pretty cool, right? Even in a country like Sweden with the highest taxes in the world, $10 million, even after taxes, is a nice chunk of change. Yeah, nothing wrong with that. But here's your second alternative. We focus on reducing the development cycle, and lo and behold, we're successful. We're 10% faster, which means that I can put my product in market after 10.8 months rather than after 12 months. And assuming I'm selling at a flat rate of $1 billion a year, and assuming I'm not cannibalizing any existing products, I'm adding $100 million of additional top-line revenue to the company. Now, what would you rather have? 10 million in savings or $100 million of additional revenue? There is something to this math thing, I can tell. Obviously, look, you've earned back your entire R&D budget just by being faster. That's why speed matters. Put stuff in market quick so you can start to monetize it and generate revenue of it. No efficiency improvement will outperform cycle time reduction. Nada. Nothing you can do. Stop talking about efficiency. Start talking about speed. I think that that's critically important in industry. Now we're moving towards this new business ecosystem. I'm going to introduce a very simple model called the 3-layer product model. I'm not a terribly smart person, so I can only do simple models. We have a commodity functionality layer at the bottom. For every product, there's a layer of commodity stuff that you need for your product to work. But no customer is going to pick your product over a competitor's product because of that functionality. But for instance, when you picked your new mobile phone, the fact that you could make calls with that mobile phone did not factor into your selection process. You would have been really annoyed if you couldn't make phone calls, but it didn't matter. The fact that you could make phone calls with the call did not make you choose between your iPhone or your Samsung or whatever you were choosing between. Then there is a layer of differentiating functionality. Differentiating functionality is what makes you pick a certain product over its competitor. Yeah, so that's, I don't know, Nokia soon coming out with a mobile phone with 5 cameras. I don't know why you need 5 cameras on the phone, but for some people that are really into it, probably that will be a differentiator for them. And then on top of that, we have the innovation and experimentation. And how this typically works in practice is that I try out 10 different ideas. Out of those 10, typically 1 is successful. So what happens is that I productize that 1 successful innovative idea and I put it in my differentiating functionality layer, and it sits there for a while, and then it commoditizes, and then it flows down in the commodity functionality layer. Now, what does this mean? What are the questions that a company needs to answer in order to be successful in business? Well, the first is, how do I expand my innovation funnel? How do I get more ideas into my products so I can have more differentiation? Well, for this, you need to partner with your ecosystem. Once I identify something that I really want to have in product, how do I get it there? Well, here I focus on speed. Then once I know how do I know that what I'm actually putting out as what I think is differentiating is actually differentiating for customers? Well, here data comes in. How do I know that when something that was differentiating is starting to commoditize? Well, again, here I need data. How can I share and minimize the total cost of ownership for myself? And for this, I partner with my ecosystem again. And then finally, how do I organize in a system like this? And then we get to empowerment. Yeah? So what I'm basically claiming is that we're moving towards a new digital business operating system which has 4 important dimensions: speed, data, ecosystems, and empowerment. And what I'm going to do now is, for the rest of the talk, is to go through each of these 4 dimensions in roughly 5 minutes each, because otherwise I'm running out of time. So if we look at the speed dimension, I can see that all companies, and we've studied dozens of companies, they all evolve in the same way. The first is we go from traditional development to adopting agile practices. Anyone here working with agile practices? Yeah, there are a few hands that are going up, so you all know agile, right? Now the next step after that, once you have agile in place, is that you move towards continuous integration, because all those teams want to know if the stuff that they're building is actually working. So then you have continuous integration, and this is where R&D and verification come together. And the interesting thing is that when you get really good at continuous integration, you will never have to worry about when you're able to ship or when you're not able to ship, because your software is always at production quality. Deciding when to ship basically becomes a business decision, not something where R&D is holding back the rest of the organization. Once you get good at that, many companies then move towards continuous deployment. Yeah, people used to think, oh, this is only the Ericssons and the Facebooks of this world that are doing that. But Ericsson today is releasing new software in live base stations with selected customers every 2 weeks. So your base station is getting better every 2 weeks. New functionality, new features, improved performance, etc. is being pushed. And once I have continuous deployment in place, and Ericsson is by far not the only company that is doing this in the embedded system space. Many other companies are doing the same thing. I can move towards R&D as an innovation system. I can start to work with my R&D by testing out different realizations of features, doing A/B testing in the field. Yeah? For those of you owning a Tesla, are there any Teslas here in Poland? There are a few Teslas. Every couple of months, basically, you wake up and there's a new version of the software basically taking place. And I can talk about how that works. But basically, we're moving towards a world where every system you touch, even if it has functional safety or security concerns, will get new software very, very frequently. Yeah, it's important to realize that. Why is this? Well, what we talk about is that there are 6 feedback cycles: the development cycle, the requirement cycle, the quality assurance cycle, the governance cycle. And with governance we mean how much resources go to features, how much resources go to quality assurance, how much resources go to architecture refactoring, the deployment cycle, how often do I get my stuff out to customers, and then finally the value creation cycle, how often do I verify that what I'm building is actually adding value to customers, and we're going to come back to that. And if you see it to it, is that with every step, you can see it up there, traditional, agile, continuous integration, continuous deployment, and then the innovation system, with every step you go up, one of those feedback cycles goes from being long to being sprint-based. And why is this important? When I have a long feedback cycle, people make opinion-based decisions. They will say things like, I've been in this industry for 30 years, I know exactly how to do this, and we're going to do it like this. And when you have a sprint-based process, you can start to move towards data-driven decisions. We've tried alternative A, we've tried alternative B. Alternative B performs better in the field, customers like it better, the product performs better, or whatever metric I care about. And based on that, I then choose B over A. Not because of opinions, but because the data tells me what is the right answer. Yeah, and that is, I think, quite important. Now, we've done quite a bit of work in this. We've done work on architecture technical debt. If you're interested in that, come and talk to me. We have lots of cool things going on here, things like contagious technical debt, which spread like a virus in the system, for those of you that are into software engineering. We've also looked into visualizing all the continuous integration activities that happen in a company.
For instance, this is a Swedish telecom company that shall remain unnamed. Whenever any developer checks in code, first he or she runs the test cases that he or she has developed as part of test-driven development in his or her own sandbox. Then it goes into the team sandbox and there is some additional testing taking place. Then if it passes that, it goes to the acceptance testing of the main branch. Yeah, if you still have branches in your company, stop doing that. When it passes the acceptance testing, it goes into the main branch. Every 2 hours, and that's the column there, sorry, my laser pointer doesn't work on the screen. Every 2 hours, there's a fully automated test suite that grabs all the software, creates an executable, and runs it through all the test cases that fits in a 2 hour window. Then every evening at 8 o'clock, why at 8 o'clock? Well, that was the only way they could get engineers to go home early, yeah, before 8, because everything you check in later would only be tested 24 hours later anyway. Yeah, so every evening at 8 o'clock they would start a 10-hour test suite that fully automatically ran all the test cases that fit into a 10-hour test suite. And then every Friday evening at 8 o'clock they kicked off a 50-hour test suite, fully automatic for all the software on 3 different hardware platforms, and they ran all the tests that would fit in the 50-hour window, which was basically almost all their tests. And then at that point they still had a separate release organization that took over. So if you're interested in this, I'm happy to talk to you about this. This one I'm going to skip over in the interest of time. Data. Companies move through their evolution of data in a very predictable pattern again. We identify 4 stages: the collection of data, the analysis of data, the reporting of data, and decision making based on data. Yeah? And if you're in the ad hoc stage, all those things are manual. Once you get to the collection stage, the collection of data is automatic, but analysis, reporting, and decision making is still manual. What many of you do not know is that when you go put your car in service, the first thing that the technician does is basically plug into your car, and they suck out all the data from your car that has been there since the last time it went to service. And the automotive industry has been doing that since the late 90s. But for the first years, all that data just went into a black hole. Then you go to the automation stage. Their collection, analysis, and reporting is automated, and the intent is to support decision making. The idea here basically is that you get those dashboards. You've all seen dashboards where there's constantly data coming in and you get updates on that. The next stage after this is data innovation. And we work with one game company, a mobile game company that I will not mention because this is being recorded. But in this game company, it offers free mobile games. And what it has is in the game, it's a puzzle game, and in the game you can buy gems. Yeah, so if you cannot solve the puzzle, you can buy a little thing that helps you solve the puzzle. Are you with me so far? Yeah? Everyone is going like this. Yeah? So when you get to data innovation, what you get to is a state where the data analysis starts to become automatic. So while you're playing this game, the first analysis that happens is that your player behavior is compared to millions of other players. And the first thing that gets asked is this player stuck at this level in the game? And if it turns out that you're not stuck, the game will do nothing. If the game determines that you're stuck at this level in the game, it will start a second analysis. And the second analysis is, how likely is this player to buy a gem from us if we just let the player suffer, based on what we know about millions of other players playing the same game? And if it turns out that you're likely to buy a gem, the game will just let you suffer until you whip out your credit card and you actually buy the little gem that will help you solve the puzzle. If it turns out that you're not likely to buy a gem at this point, the third analysis starts. And the third analysis basically says, based on what we know of this player and of millions of other players, how likely is this player to buy a gem at a later stage in the game if we just help the player to get there? And if it turns out that you're unlikely to buy a gem now because you're a Dutch cheapskate like me, yeah, but you may be likely to buy a gem later in the game if you're more invested into the game may decide to give you a free gem. How cool is that? Everyone goes like, ah, Jan, that is amoral, that's unethical. That's one way to look at it. The other way to look at it is, you know, it's running a business. And if you look at companies like Spotify, anyone using Spotify are in the room? Yeah? Yeah, almost all of you. main reason why most of my friends use Spotify is not because of the access to the music, but to actually find music that they would have never found otherwise because of data analytics that Spotify does in the background. Because they know that people like you like this band and you've never listened to this band, so you should really be exposed to it. And then finally, the evidence-based companies, when everything in the company is basically data-driven. When I worked for Intuit at Google, several of my friends there told me how performance evaluations happen at Google. Your boss has nothing to do with your performance evaluation. And considering the fact that at that point the average manager had between 150 and 200 direct reports, the manager would probably even not know you, to be very honest. Now what happens is that 6 people are asked to give feedback on you. 3 from the same team that you're part of, and 3 from other teams that you collaborate with. And as part of their evaluation, they have to give you 3 names of people that perform, according to them, less good than you, 3 names of people that they consider to perform as good as you, and 3 names of people that they consider to perform better than you. Now if you, for every individual in the company, from 6 different sources, get 9 different names, you can basically do a mathematical calculation from the most valuable individual in the company to the most useless piece of human being in the company, and then salary increases and bonuses basically become a mathematical formula. You still with me so far? Sounds like Nirvana, right? Yeah, in Sweden. Let's do it here. That's an interesting one. Yeah, you were a little against numbers, I think, if I remember correctly. Why do I care so much about data? I have to talk faster because I have 10 minutes left. Is this okay so far? Can I go faster? Yes, you sure? Okay, good. And we have questions too. Okay, I will talk even faster. This is an old study that many people have seen, and it's highly criticized, which basically says that of all the features that exist in a typical IT system, somewhere around 2/3 of those features are used so seldomly, if at all, that the R&D investment in those features was not justified. Yeah? So we did our own research in Gothenburg with a company that wanted to remain unnamed, but we see exactly the same patterns. Some features are used a lot, some features are used occasionally, and the vast majority of features is never used. So remember this, of all the new features we built, half of those features at least are waste. Shouldn't have been built. Yeah, so how do we get around that? Well, for this, the way we get around that is we use, for instance, the HYPEX model. What we basically say is you pick a feature, you agree with product management. If I build this feature, how is my customer going to behave different? How is my system going to behave different in such a way that it justifies investing in this feature? And then you build a minimal viable feature, the smallest slice of feature that actually gives some value to customers. You also add instrumentation to your product. You measure what is the actual behavior, and then you have 4 different outcomes. Either you build 25% of the feature, you got everything you wanted, you're basically done, and you basically move on to the next feature without building the rest. Or you build 30% of the feature, you don't see any movement. Nothing happens. And what you should then do is to basically abandon the feature, remove the code from your system and move on to something else. It may also be that they say, you know, we should build more of the feature. You see some movement, but not all of it. So I built some of the feature. I have to add more of it in order to get the full effect. Or finally, I get the data back. I see that customers kind of want it, but not in the way that I built it. So I built an alternative implementation of my feature. And this brings me to, I have to talk even faster, to what we call the holistic DevOps framework. We see going forward that there are 3 types of development that software engineers have to contest with. The first is traditional requirements-driven development. Product management throws requirements over the wall and basically says, build it. And then you go and build it. Yeah? That's requirements-driven development. The second is what we call outcome or data-driven development. That's when I run A/B experiments. Companies like Microsoft and Booking or Skyscanner run thousands of A/B experiments concurrently in their systems to measure if version A of a feature or version B of a feature is a better solution. And then they do multivariate statistical analysis to determine what is the best way to realize something. The third type of development is what we call AI-driven development. I have large data sets. These data sets have been labeled so I can use them for training. And then I use machine learning and deep learning solutions to actually create trained models that I can then put as components into my system, because every component in this system will have continuous deployment and data, behavioral data being sent back, which will basically then drive development. Can you see this so far? And I know that we have people that are big on AI in the room, because I started several events around AI. Why do I care so much about software engineering for AI? Well, here's a paper from Google. Some of you may be aware of it. But what they basically showed was the architecture of a deep learning system. And what you see is that there are several very big boxes there. Configuration, data collection, feature accession, data verification, machine resource management, analysis tools, process management, serving infrastructure, monitoring, everything else. And then a tiny box in the middle that says machine learning code. Did you notice that? So if you're working on AI, that's cool. I love you to pieces because of it. But please realize that the software engineering challenge of building machine learning, deep learning applications that you can deploy in a mission-critical production quality environment has severe software engineering challenges. I'm on the board of a company in Stockholm called Peltarion that is trying to solve exactly this. And together with the founder and a few other people working at that company coming from, you know, big Swedish startups like Spotify and King & Klein and others that have this background, we looked at what are the challenges that people have when they build deep learning systems. So what are the software engineering challenges for deep learning? And what we say is that there are three categories: development challenges, production challenges, and organizational challenges. Some of those are really hard to solve, some are easier to solve, some have a high business impact, some have a lower business impact, but there are several challenges around building deep learning systems at production quality that I really would like to invite you to go and look at. 7 minutes. How am I doing so far? You okay? Still awake? Come on, guys. Show me some energy. Are you still awake or not? Woo! Okay, good. Ecosystems, yeah? So I'm not going to talk about any of this ecosystem, but I hope you remember this figure from the beginning. You remember this figure? Yeah, commodity, differentiation, innovation, experimentation. I've now asked well over 50 companies, of all the R&D effort in your company, how much goes to commodity and how much goes to differentiation, innovation, experimentation? You want to know the answer? The answer is that somewhere between 80 and 90% of all R&D resources in a typical company go to commodity functionality. Stuff that no customer gives a flying hoot about. It should just work. So the state of software engineering today is that out of every 10 people in R&D, 8 or 9 are working on stuff that no customer cares about, and the 1 or 2 people that are building new stuff get it wrong around half the time. I cannot help think that there is a slight room for improvement here. I hope you agree with me on that. We worked on a model called the 3-layer ecosystem strategy model that I will not talk about, but basically it says there's a whole bunch of strategies that you can use to actually decrease the amount that goes into commodity. I wanted to talk a little bit about empowerment, yeah, because this is my favorite slide in the whole deck. Gaping void is not me. It basically says the frontline people are losers, the people in the middle are clueless, and the people at the top are sociopaths. Now, you can agree or disagree with that statement, but what we see is that there is a trend away from hierarchical organizations to more empowered organizations. There are again 5 steps. I'm not going to talk about those, but what is important to realize is that hierarchical organizations are very good for scaling, controlling many people, repeatable tasks, harmonization, process, globalization, and handling low complexity situations. They are very poor at, because they have slow decision-making processes, and speed is important. Power is driven by position, not capability. We all have worked for a boss that was an idiot, typically a guy for all the women in the room, that's for the record, although there are also female, not so nice bosses. Power is driven by position, not by capability. There's a tendency to be internally focused. I do some work with a very large German company, where I ran into a case where a middle-level manager could decide between doing one of 2 things. The one thing was doing something that was bad for the company and bad for his competitor. And the other thing he could do was something that was good for the company and neutral for his competitor. Guess what he chose to do? The first option, exactly. So tendency to be internally focused, easily gravitates to politics, not in Poland, I know, but in other countries. Highly resistant to changes and challenged by high complexity situations. So hierarchies are good for all the work that we are currently automating. All the work that is done by humans requires something else than hierarchy. And we can see this. Employee engagement in the US, yeah, very quickly, I'm almost done. 30% of employees is engaged in their job, right? 50% is not engaged, and on average 18% of people is actively disengaged. You know what it means? It means they hate their job so much that if no one is watching, they will kick the printer and hope that it breaks. Yeah, if I'm the truck driver working for the company, I will take boxes and I will dunk them as hard as I can in the back of the truck, hoping that they break. Because I hate working here so much that I just want to hurt the company. Yeah? And now I can see all of you think, Jan, of course, this is the US. You live in Sweden, it's much better in Sweden, right? Right. 16% of people is engaged in their job. 73% of people is not engaged in a job. And the only good news on this thing is that 11% of people is actively disengaged. Only 11%. Only a little over 1 in every 10. Yeah? And this is, the younger you are, the less you fit in a traditional hierarchical organization, which I think is a big problem. And there are huge economic benefit or damages from this. So what we see is that at the other end of the spectrum, there is a new form of organizations developing that are organized around self-management. There are no bosses. Around wholeness, I don't have time to go into what that means, and basically evolutionary purpose. And what this means is that people take on roles, and you can voluntarily take on the role and relinquish a role. There's something called the advice process, which I thought was a really interesting one, because I used to think either you need a boss to tell everyone what's going to happen, or you need to have consensus. But in one of the books that I'll show you on the next slide, basically a blue-collar machine worker in a factory could decide to order a €1 million machine if he or she had asked advice from all the people that were affected by their decision. By that decision. So his or her fellow machine workers had to be asked, the finance department had to be asked, can we actually afford this? Sales had to be asked, this will increase our output, can we actually move that much good, etc., etc. But once you had asked all the relevant stakeholders for advice, you could still decide you were responsible for making a decision. That's the advice process, which I think is quite interesting. You have agreements and you have evolution. And if you look at examples, Agile is a first step on that road. That's why I brought it up here, because Agile fits this pattern. There's a book called Reinventing Organizations by Frédéric Laloux, who basically says that humanity is moving from tribal to agrarian to scientific industrial to the postmodern information to now the holistic, authentic society. Holacracy, you may have heard of that. Zappos adopted Holacracy last year, I think. And then there is a book called Exponential Organizations, which talks about how companies like Uber and Airbnb can grow so rapidly, so big. And what they basically talk about is, again, autonomy, dashboards, interfaces on the inside, and experimentation, which you cannot read there right now. So what we see in companies is that we are moving from orders to empowerment, from leader-follower to personal leadership, from audits, I'm going to audit you, to trust, to organizational structure first, to customer first, from manager-appointed teams, I'm the boss, I decide who works for me, to team-appointed managers, which I think is a really interesting one, from diversity, from homogeneity to diversity, from long-term planning to agility, and then finally from top-down strategy, we're going to go this way, to an emergent strategy, because it basically allows you to capture all the intelligence of all the people that work for you in the organization. Conclusion. Our chair of this session has never been so happy to see a slide that says conclusion, and I'm only 1 minute over time, including the technical difficulties I had in the beginning. In the future, all companies will be software companies. I don't care if you're a bank, you're a software company. If you're a retail company, you're a software company. If you're a factory, you're a software company. The world is run by software and data. Yeah, it's really important to realize that. Speed is kind of, sort of important. Did I convince you of that? If you say yes, it goes faster. Did I convince you of speed? Yeah. Data and ecosystems are important. Yes? Yes. Good. This whole thing of empowerment and autonomy is interesting and we should learn more about it. Yes? Very good. Now with that, if you want to learn any more, there are 3 books. The first one I signed away the copyright of, but the other two, you know, just because I love you so much, I'm willing to send the PDF of those short books to you for free if you send me an email at jan@janbosch.com. One is around using data to build better products, and the other one is how do I use this 3-layer product model to actually reduce the investment in the commodity and increase the investment in differentiating functionality. That's pretty cool, right? Yeah, otherwise you would have had to pay $9.99 just for the record, you know? And with that, my friends, thank you very much for your attention. I appreciate it.